The 1970s dial-up problem. Deep space exploration is currently strangled by a bandwidth bottleneck that has not fundamentally changed since the Viking landers. While our sensors capture gigabytes of high-fidelity multispectral data, we are still pushing those bits through X-band radio links that max out at roughly half a megabit per second from Mars. It is the equivalent of trying to download a modern 4K video over a 1996 telephone line. This spectral congestion is the hard ceiling on how much science we can actually retrieve. But as of April 2026, the data from NASA's Deep Space Optical Communications test on the Psyche mission confirms we have finally broken the radio wall, the physics of frequency. The throughput delta comes down to wavelength. Radio waves are long and dissipate over distance, requiring massive 70-meter ground antennas to capture a faint, wide signal. Laser communication uses near-infrared light at 1550 nanometers. Because these waves are thousands of times shorter than radio, they can be packed with significantly more data and stay tightly focused over hundreds of millions of miles. In recent tests, DSOC achieved 267 megabits per second from 19 million miles away. Even at maximum Mars distance, the system maintained over 6 megabits per second. This is not a marginal gain. It is a 10 to 100-fold increase in how much information we can pull from the inner solar system using a transceiver that weighs less than a standard radio package. This density advantage changes the fundamental mass-to-data ratio for mission planning. The Arcsecond Precision Challenge. Precision is the primary constraint. Aiming a laser from the asteroid belt to a telescope on Earth is the mechanical equivalent of hitting a moving dime with a pointer from 2 miles away while you are standing on a spinning top. The beam is so narrow that a deviation of just a few arcseconds means the signal misses Earth entirely. DSOC solves this using an isolation pointing assembly that filters out spacecraft vibrations, allowing the laser to remain locked on a ground-based beacon with sub-microradian accuracy. This level of mechanical stability is the only reason optical links are now viable for deep space. Calculating the point-ahead gap. At 240 million miles, you cannot aim where Earth is. You have to aim where Earth will be 20 minutes from now. This is the point-ahead problem. Because light takes time to travel, and both the spacecraft and Earth are moving at thousands of miles per hour in their respective orbits, the laser must lead the target by a specific delta. The DSOC terminal on Psyche calculates this lead angle in real time, accounting for velocity aberration and the exact position of the Hale telescope at Palomar Observatory. To catch these photons, Palomar uses a specialized superconducting nanowire detector cooled to near absolute zero, capable of counting individual particles of light as they arrive. This hardware chain represents the most precise long-distance alignment ever sustained in aerospace history, and with Psyche's Mars flyby scheduled for next month, we are about to see if the system can maintain this lock during a high-velocity gravity assist. Where this is headed. The success of DSOC marks the transition from event-based science to environment-based science. For decades, we've designed missions around the assumption that data is a scarce resource, forcing scientists to pick and choose which specific frames to send back. By commoditizing deep space bandwidth, we shift the requirement from sparse telemetry to continuous high-definition streams. This is the technical foundation required for human Mars exploration, where medical monitoring, habitat telemetry, and high-res geological mapping will demand gigabytes of daily throughput. The constraint is no longer the physics of light, but the funding for a global network of optical ground stations. While the prime DSOC mission ended in late 2025, the hardware remains functional for the upcoming Mars encounter. The real indicator to watch in late 2026 is whether NASA secures the budget to operationalize this as the primary link for the next generation of Mars landers. If they do, the era of the low-gain radio ping is over. Subscribe for more.